In this video, we're going to learn how to solve something called a rational equation. Some important things to note as we begin learning how to solve these. Rational equations are ones that contain fractions with variables in them. In particular, the variable occurs in a denominator. We'll see that rational equations have restrictions on their solutions, and those matter before we even begin solving them. We'll also find that the technique for clearing denominators that we used when solving linear equations that involved fractions will be useful to us when we solve rational equations. Let's take each of these ideas one step further. A rational equation is one that can be written in the form p of x over q of x equals r of x over s of x, where p of x, q of x, r of x, and s of x are all polynomials. In other words, they're sums of powers of some variable. The restrictions on a rational equation are driven by the denominator. We know that we can't divide by 0, so we're going to automatically exclude any values of our variable that make the denominator equal to 0. Lastly, what we're going to do is we're going to construct the least common denominator, or LCD, of all of our denominators by using factoring techniques, and then we're going to multiply our expression through by that denominator in order to clear our fractions. Let's start with a fairly straightforward example. Here we have the expression 2 over x plus 1 is equal to 3. We know that this is a rational equation because, first of all, it's an equation, it has an equal sign in it, and we have a variable in the denominator. We're going to start off by figuring out our restrictions. Remember that the restrictions are any numbers that make a denominator 0. We only have one denominator here, it's x. If that is 0, that's a problem. So we know automatically that x cannot be 0. Now we're going to figure out our LCD. Once again, we only have one denominator. That automatically makes that denominator the LCD. We're now going to multiply through. Just like for linear equations, we have to remember that we are going to multiply every term by our LCD. Here we have 3 terms. 2 over x is our first term. We have a addition sign, which tells us that we're coming up to our next term. Then we have an equal sign, which tells us we're approaching our third term. So we're going to distribute the x to each of these terms, and that is going to give us the expression x times 2 over x plus x times 1 equals x times 3. Notice, just like for linear equations, when we multiply by our LCD, the denominators cancel. So now we have the expression 2 plus x is equal to 3x. This is now a linear equation. We use our technique of isolating the variable by using opposite or inverse operations in order to solve the resulting linear equation. So we'll subtract x from both sides, and that gives us that 2 is equal to 2x. And now we'll divide by 2 on both sides to get that x is equal to 1. Let's check. We're going to check by replacing x equals 1 for all of the x's in our equation. So we'll say 2 divided by 1 plus 1. Well, that is in fact equal to 2 plus 1, which is 3. So our solution worked. Let's try one more. Here we have x over x minus 1 equals 2. Again, we have a polynomial over a polynomial on the left, and then we just have a number, which is a polynomial of degree 0 on the right. So this is a rational equation. So we're going to look for our restrictions first. In other words, we're going to examine where are any of our denominators equal to 0. That would mean x minus 1 is equal to 0. Solving that, adding 1 to both sides, we get x equals 1, but that's a restriction. So we now know that x can't be equal to 1. So if when we go through the work of solving this thing, we get x equals 1 as an answer, we would have to rule that out. Our LCD, because we only have one denominator, is going to be x minus 1. We're going to multiply through by that. So we do x minus 1 times the entire expression. This thing only has two terms, one on each side. Term 1 here, term 2 here. When we multiply through by x minus 1, we get x minus 1 times x over x minus 1 equals x minus 1 times 2. Again, we note that on the left-hand side, the x minus 1's cancel. So now we have the expression x equals 2x minus 2. We can subtract 2x from both sides in order to get our x's on one side together. X minus 2x is negative x, so we have negative x equals negative 2. Dividing by negative 1 gives us x is equal to positive 2. Let's check it. Our original equation was x over x minus 1 equals 2. If we replace all of our x's with 2's, we get 2 over 2 minus 1, which is 2 over 1, which does in fact equal 2. All right, let's take a look at this next one. You can see we've kind of upgraded the complexity a little bit, but our steps are going to remain the same. We're going to look for restrictions, then we're going to find an LCD and multiply through by it, and then we'll solve the resulting equation. All right, so here our restrictions are going to be any values that make any of our denominators 0. So if we take the denominator x times x minus 3 and set that equal to 0, we can see that we get x equals 0 or x equals 3. So we can rule those two values out. If we take the denominator x plus 3 and set it equal to 0, then that gives us that x is equal to negative 3. The last denominator, x minus 3, was built into the first denominator, so we don't have to consider it again. We see that our three restrictions are x equals 0, 3, and negative 3. So when we solve this thing, if any of those comes out to be an answer, we have to rule it out. Next, we're going to build our LCD. All of the factors of any of our denominators have to be included in our LCD. So if we look at our first denominator, it contains the factors x and x minus 3. So we build those into our denominator, into our LCD. The first fraction is taken care of. Our next denominator involves x plus 3, which is not included in our LCD yet, so we'll add it. And now we've captured our second fraction. When we look at the third fraction, we can see that it has an x minus 3 in it, which is already in our denominator, so we've captured that. We're not going to multiply the LCD out. That just makes our lives complicated when we try to cancel with our fractions in the next step. So we'll go ahead and multiply through. So I'm going to take my LCD, and I'm going to multiply it by every term in our expression. So we're going to multiply by 2 times x minus x, 2 over x times x minus 3. And then we're going to repeat that with our second term, 5 over x plus 3. And then we'll complete that with our last term. And now we'll look at our cancellation. So in the first term, the x's cancel and the x minus 3's cancel. And we're left with 2 times x plus 3. In our next term, the x plus 3's cancel, and we're left with 5 times x minus 3. In our last term on the right-hand side, the x minus 3's cancel, and we're left with x times x plus 3. Our last remaining task is to solve this resulting equation. So we'll distribute everything and simplify this. We get 2x plus 6 plus 5x squared minus 15x equals x squared plus 3x. And I got that by distributing the 2 across the parentheses, the 5x across the parentheses, and the x across the parentheses. Now we'll combine some like terms. So notice on the left-hand side, I have a 2x and a negative 15x. So that becomes 5x squared minus 13x plus 6, and that's equal to x squared plus 3x on the right. We can see what we have here now is a quadratic equation. And since we have multiple powers of x inside of this, we're going to solve it using either factoring or the quadratic formula. So we need this entire thing to be equal to 0. So we're going to move our terms around. We're going to subtract x squared and 3x from both sides, giving us 4x squared minus 16x plus 6 equals 0. We can simplify things a little bit by noticing that all of these are divisible by 2. So we'll go ahead and divide everything by 2. We can do that on both sides. Remembering that when we do it on the left-hand side, the 2 divides every single term. So we're going to get 2x squared minus 8x plus 3 equals 0. Now we can use the asterisk or the AC method to contemplate whether this factors. We need factors that multiply to be 6 and add up to be negative 8. Well, the factors of 6 are 1 and 6 or 2 and 3. None of those are going to give us 8. So we are stuck using the quadratic formula. We have an a value of 2, a b value of negative 8, and a c value of 3 in our quadratic. So we're going to see that x is going to be equal to negative b is positive 8 plus or minus the square root of b squared is 64 minus 4 times a times c, all divided by 2a. That gives us 8 plus or minus the square root. 4 times 2 times 3 is 24. So we have 64 minus 24, which is 40, all over 4. 40 is 4 times 10, so we can bring out the square root of 4, which is 2. So we have 2 square roots of 10 over 4. And we can think of this as 8 over 4 plus or minus 2 root 10 over 4. 8 over 4 is 2. So we get 2 plus or minus the square root of 10 over 2 as our solutions. None of those are equal to 3, so they are all valid solutions, and our final answer is x equals 2 plus or minus the square root of 10 over 2. Okay, let's take a look at one more example, and this one is fairly straightforward, but it's hopefully going to demonstrate for us why we have to check our restrictions. So let's start by factoring. Notice that the denominator on the right-hand side is not factored, so we're going to factor that as x plus 1, x minus 1, since the difference of squares. So if we look for our restrictions now, setting our denominators equal to 0, we see that x minus 1 is 0, tells us that x can't be 1, and x plus 1 times x minus 1 equals 0 is also going to give us that x cannot be negative 1 from the x plus 1 factor. So we see that x cannot be either positive or negative 1. Now we'll build our LCD. We're going to need an x plus 1 and an x minus 1 in order to capture all 3 of the factors in our denominators. Let's multiply through by that. So we have x plus 1 times x minus 1 times 2 over x minus 1 equals 4 over x plus 1, x minus 1 times x plus 1, x minus 1. And now we'll cancel. So when we cancel, on the left, the x minus 1's cancel, and we get 2 times x plus 1. And on the right, both terms cancel with their corresponding factors, and we get 4. Now we solve. We get 2 times x plus 1 equals 4, which means that 2x plus 2 equals 4. Subtracting 2 from both sides, we get that 2x is equal to 2, which gives us that x is equal to 1. But remember this is a restricted value. This makes one of our denominators 0, which means that it can't possibly be a solution, which means that our equation has no solutions. The only one we came up with when we did the algebra was one that was a restricted value, and so our equation doesn't have any solutions at all. Okay, now that we've worked through some examples, let's summarize what we know and take a look at what we're going to look at next. So rational equations are ones of the form p of x over q of x equals r of x over s of x, or ones that can be rewritten into that form, where all of the pieces are polynomials in some variable. We're always going to start off by noting any restrictions. We'll then proceed to construct an LCD using the factors of our denominators, and then we can clear all of the fractions by multiplying all terms by our LCD. Once we've done that, we're going to solve the remaining equation. Sometimes it'll be linear, sometimes it'll be quadratic. Our solutions will then come from that new equation as long as we eliminate the restrictions that we found earlier. The next thing we're going to take a look at is something called radical equations.